Model distillation in distributed systems with AWS and SageMaker. Definition: model distillation involves transferring knowledge from a complex, large model teacher model to a simpler, smaller model student model through supervised learning, optimizing performance, reducing computational resources, and improving overall efficiency in distributed systems for large language models (LLM) and retrieval augmented generation RAG projects. Leveraging AWS, Amazon Web Services and SageMaker. Key components: AWS services, SageMaker, fully managed service for building, training, and deploying machine learning models at scale. Integrated with AWS services for model distillation in distributed computing. EC2 instances. Elastic Compute Cloud instances for provisioning virtual servers with varying compute capacities and optimized hardware configurations. AWS Lambda, serverless computing service for executing code in response to events, optimizing resource usage and scaling model inference in distributed deployments. AWS Elastic Beanstalk, service for deploying and managing applications in the cloud, automating resource provisioning and scaling for distributed computing environments. AWS Nitro System, hardware and software infrastructure that accelerates and optimizes storage, compute, and networking tasks, improving overall system performance. Model distillation techniques. Knowledge transfer. Transfers knowledge from a teacher model complex, large model to a student model simpler, smaller model through supervised learning, optimizing model size and improving efficiency in distributed setups. Mimicking loss. Uses mimicking loss functions to guide the student model's learning process, enabling it to replicate the predictions and behaviors of the teacher model in diverse workload scenarios. Teacher ensembling. Ensembles predictions from multiple teacher models to provide diverse and robust training data for the student model, enhancing performance and generalization capabilities. Parameter compression. Compresses model parameters and representations during distillation to reduce computational complexity and memory footprint in distributed computing environments. Benefits. Improved performance. Enhances model inference speed and accuracy by transferring knowledge from a complex teacher model to a simpler student model. Optimizing computational resources in distributed systems. Reduced computational resources. Lowers memory footprint and storage requirements by distilling model knowledge and compressing parameters. Optimizing resource allocation and improving cost efficiency. Scalability and flexibility. Improves scalability and flexibility in distributed environments by deploying distilled student models that require fewer computational resources and support diverse workload demands. Cost effectiveness. Optimizes operational costs and resource utilization by deploying distilled models that achieve performance gains with reduced complexity and enhanced efficiency in distributed setups. Knowledge transfer. Facilitates knowledge transfer and learning from complex teacher models to simpler student models. Improving model understanding and performance in distributed computing. Tools and technologies. AWS SageMaker. Fully managed service with built-in algorithms and frameworks for implementing model distillation techniques and optimizing model performance in distributed computing. AWS EC2 instances. Elastic Compute Cloud instances for provisioning virtual servers with optimized hardware configurations and scalable compute capacity in distributed deployments. AWS Lambda. Serverless computing service for executing code in response to events, automating model inference tasks and optimizing resource usage in distributed environments. AWS Elastic Beanstalk. Service for deploying and managing applications in the cloud. Automating resource provisioning and scaling for distributed computing setups. AWS CloudWatch. Monitoring and management service for tracking model performance metrics. Optimizing resource utilization. And scaling model inference in distributed systems. Challenges. Knowledge transfer complexity. Managing complexities associated with transferring knowledge and learning from a complex teacher model to a simpler student model in distributed computing environments. Compatibility and integration. Ensuring compatibility and seamless integration of distilled models with existing software, frameworks, and infrastructure in distributed setups. Distillation method selection. Selecting appropriate distillation techniques and strategies based on model requirements and performance metrics to achieve optimal learning outcomes in diverse workload scenarios. Data integrity and accuracy. Addressing potential issues related to maintaining data integrity and accuracy when distilling knowledge and compressing model parameters in complex machine learning models. Training and skills. Building expertise and skills in implementing and fine-tuning model distillation techniques to maximize performance gains and efficiency in distributed computing environments.